The Sikorsky CH-53K KingStallion, Sikorsky S-95, is a heavy-lift cargo helicopter designed and produced by Sikorsky Aircraft. The KingStallion is an evolution of the long-running CH-53 series of helicopters which have been in continuous service since 1966, and features three uprated 7,500 shp, 5,590 kilowatts, engines, new composite rotor blades, and a wider aircraft cabin than its predecessors. It is the largest and heaviest helicopter in the U.S. military. The United States Marine Corps plans to receive 200 helicopters at a total cost of $25 billion. Ground Test Vehicle (GTV) testing started in April 2014. Flight testing began with the maiden flight on the 27th of October 2015. In May 2018, the first CH-53K was delivered to the Marine Corps. On the 22nd of April 2022, it was declared to have passed initial operational capability. 3. Israel has also reportedly ordered the type. Other potential export customers include Japan and Germany. The Sikorsky CH-53C Stallion came out of the U.S. Marine Corps' USMC Heavy Helicopter Experimental HHX competition begun in 1962. Sikorsky's S-65 was selected over Boeing Vertol's modified CH-47 Chinook version. The prototype CH-53A first flew on the 14th of October 1964. 4. It was designated CH-53AC Stallion. Delivery of production helicopters began in 1966. 5. The CH-53A was equipped with two T64GE6 turboshaft engines, and had a maximum gross weight of 46,000 pounds, 21,000 kilograms. Variants of the original CH-53AC Stallion include the RH-53A, D, HH-53B, C, CH-53D, CH-53G, and MH-53H, J, M. The RH-53A and RH-53D were used by the United States Navy for minesweeping. The CH-53D had a more powerful version of the General Electric T-64 engine, used in all H-53 variants, and external fuel tanks. 4. The U.S. Air Force's HH-53B, C Super Jolly Green Giant were for special operations and combat rescue. The Air Force's MH-53H, J, M Pave Low were the final twin-engined H-53s, and had extensive avionics upgrades for all-weather operation. 4. In October 1967, the USMC issued a requirement for a helicopter with a lifting capacity 1.8 times that of the CH-53D, that could fit on amphibious assault ships. Before this, Sikorsky had been working on an enhancement to the CH-53D, under the company designation, S-80, featuring a third turboshaft engine and a more powerful rotor system. Sikorsky proposed the S-80 design to the Marines in 1968. The Marines considered this a good, quick solution, and funded development of a testbed helicopter. 6. Changes on the CH-53E also included a stronger transmission and a fuselage stretched 6 feet 2 inches, 1.88 meters. The main rotor blades material was changed to a titanium fiberglass composite. 6. A new automatic flight control system was added. The vertical tail was also enlarged, with the tail rotor tilted upwards slightly to provide some lift in hover. 7. The initial CH-53E first flew in 1974. 7. Following successful testing, the initial production contract was awarded in 1978, and service introduction followed in February 1981. 6. The U.S. Navy acquired the CH-53E in small numbers for shipboard resupply. The Marines and Navy acquired a total of 177. 6. For the airborne mine countermeasures role, the Navy obtained a CH-53E variant, designated MH-53E Sea Dragon, with enlarged sponsons and fuel tanks for greater fuel storage, in the 1980s. 6. 7. The Navy obtained 46 Sea Dragons. 6. The USMC had planned upgrades to retain most CH-53s, but this effort stalled. Sikorsky proposed a new model, originally designated CH-53X. In April 2006, the USMC signed a $18.8 billion contract for 156 CH-53K helicopters, with deliveries to be completed by 2021. 8, 9, 10. The USMC was to begin retiring CH-53s in 2009, and needed replacements as rotorcraft reached their structural life limits in 2011-12. 8. CH-53K flight testing was expected to begin in 2011. 11. In August 2007, the USMC increased the order from 156 to 227. 12. By that time, the first flight was planned for November 2011 with initial operating capability, IOC, by 2015. 13. The CH-53K will be the USMC's heavy lift helicopter with the MV-22, medium lift, and UH-1Y, light lift. 14. A 2007 RAND report on seabasing found that a higher ratio of CH-53 kiloseconds to MV-22s would reduce ship-based deployment times. 15. 16. In 2008, design work was well underway, along with weight reduction efforts to meet operational requirements. Increased engine performance and rotor blade improvements are options to help meet requirements if needed. The rotor mass tilt was decreased and components shifted to ensure the center of gravity does not shift too far rearward as fuel is burned. 17. Design requirements were frozen in 2009-10. 18. On the 22nd of January 2010, Sikorsky opened a $20 million Precision Components Technology Center in Stratford, Connecticut, for producing CH-53K parts, such as the rotating and stationary S-wash plates, main and tail rotor hubs, and main rotor sleeves. 19. On the 3rd of August 2010, the CH-53K passed its critical design review, readying it for test production. 2021. However, the IOC fielding date was deferred to 2018. 22. Sikorsky proposed building 4 pre-production aircraft for evaluation. 23. On the 4th of December 2012, Sikorsky delivered the first CH-53K, a ground test vehicle, GTV, airframe. Early tests included fuel system calibration and attaching test sensors across the airframe to record temperature, aerodynamic load, pressure, and vibration. 2 additional static GTVs underwent structural testing at the firm's Stratford manufacturing plant. 24. In January 2013, the program had an estimated cost of $23.17 billion United States dollars after procurement of the planned 200 CH-53 kiloseconds. 25. In April 2013, the U.S. Navy program manager stated that work had gone well and it may become operational ahead of schedule. 26. On the 31st of May 2013, the Navy awarded Sikorsky a $435 million contract to deliver 4 prototype CH-53 kiloseconds for evaluation and mission testing. 27. The first 2 prototypes focused on structural flight loads while the 3rd and 4th validated general performance, propulsion and avionics. 28. Major subcontractors include Aurora Flight Sciences, main rotor pylon. 29. Exelis Aerostructures, tail rotor pylon and sponsons. 29. GKN Aerospace, aft transition. 29. Onboard Systems International, external cargo hook. 30. Rockwell Collins, avionics management system. 31. Sanmina Sai Corporation, communications, and Spirit Aerosystems, cockpit and cabin. 29. In October 2013, Sikorsky gave Kratos Defense and Security Solutions a $8.5 million contract for CH-53K maintenance training aids, such as the Maintenance Training Device Suite, MTDS, and Helicopter Emulation Maintenance Trainer, HEMT. The MTDS is a realistic training and evaluation environment for various avionics, electrical, and hydraulic subsystems. The HEMT is a 3D simulation of multiple scenarios, such as functional test, troubleshoot, fault isolation, removal and installation of 27 subsystems. 32. On the 24th of January 2014, the CH-53K GTV ignited its engines, spinning the rotor head without rotors attached. Low-rate production is planned to proceed from 2015 to 2017. Initial operating capability, IOC, was set to occur in 2019, with full-rate production commencing between then and 2022. The USMC intends to have 8 active squadrons, 1 training squadron, and 1 reserve squadron. 33. In April 2014, testing with blades attached began, system integration followed. Flight testing was set to start in late 2014, each test aircraft flying approximately 500 hours over 3 years. 34. The maiden flight was delayed, 35, 36, due to issues with the titanium quill shafts, 37, in the transmission and gearbox. 38. On the 5th of May 2014, General James F. Amos announced during the official rollout that it will be called the KingStallion 39. On the 27th of October 2015, the CH-53K took its first flight. 40. On the 7th of March 2018, one lifted a payload of 36,000 pounds, 16,000 kilograms, the maximum weight on the single center point cargo hook. 41. 42. The first CH-53K was delivered to the USMC on the 16th of May 2018. At the time, 18 additional helicopters were in production, and the second was planned for delivery in early 2019. 43. In December 2018, the CH-53K was projected to not be combat ready as expected in late 2019, due to delivery delays caused by technical flaws found in testing, which resulted in a major program restructuring. Flaws included the engine re-ingesting exhaust gas, limited service life for the rotor gearboxes, late deliveries of redesigned parts, and deficiencies with the tail rotor and driveshaft. 44. It is estimated that the delay will push back delivery of combat-ready CH-53 kiloseconds until May 2020. 45. The CH-53K KingStallion is a heavy lift.